Hello students. So today we're going to be talking about the forces in the Earth's crust. This is from chapter 4, lesson 1 in the book, and the learning target is I can describe how tension, compression, and shearing cause normal, reverse, and strike-slip faults to form in the crust. Now this target might be a little bit more to write than some of the other ones, but it's because each of those three things relates to each other in that order. So as usual, line up your page for the Cornell notes. And once you've gotten the learning target and the title at the top, let's move on. Now, forces in the Earth's crust, here's a picture of some rock layers. Now, in geology, we know that rock layers are deposited horizontally because of Earth's gravity pulling them flat. Now, when we see rock layers like this, we know something has changed them, and the forces that change them is what we're going to talk about now. So, this is just a reminder. You can write it, you can choose to not write it, but keep this in mind. These processes happen in deep geologic time. They happen over an extremely long period of time. Obviously, earthquakes happen very quickly, and sometimes they last a couple hours with the aftershocks, but when we talk about each of these forces, they act over Earth in a long, long time scale. We call that deep time or deep geologic time, which can be in the millions, hundreds of millions, or billions of years, depending on how long and what kinds of processes. So let's start off. So stress. What's stress? In geological terms, stress is a force that can change a rock's shape or volume. Now this might be in italics, but I do want you to write this. So please get this down. In geologic terms, stress is a force that can change a rock's shape or volume. So you can see a man being pulled apart here. He's undergoing a lot of stress, just being pulled in all separate directions. So get this down because the stresses are what we're going to talk about first. Now the three types of stresses, as usual, we'll just save these for in a moment because we'll get each of those three separately, but get this as a header, three types of stresses, and you can see a picture of those right here. We'll move on. The first stress is tension. Tension is a force that pulls the crust apart and thins it in the middle. And so in this picture right here, you can see that you've got this pulling in this direction, and this pulling in this direction, and you can see that it's actually kind of thinning in the middle. So it's squishing, it's thinning in the middle. You can demonstrate this pretty easily with a piece of Laffy Taffy or some silly putty like I have, and if you pull the silly putty from both ends, you're going to have thinning in the middle. So it's getting stretched out, it's getting thinner, and we can demonstrate that pretty easily. What about if we have the opposite effect? So the next type would be compression. And so compression is a force that squeezes rock until it folds or breaks. And so right here in this picture, you can actually see this rock that used to be, they used to be in flat layers, and now you can see it's bending and folding. Eventually it might snap and that'll cause a fault, which we'll talk about next. But again, you can demonstrate this with some Laffy Taffy or silly putty. Like I have, if you take the piece and you squish it together, you might not see so much from that angle, but you can see it's kind of bulged at the middle and kind of fattened up in the middle if I turn it the other way. So compression, squeezing, tension, pulling. And the other one that's kind of unlike the other two is shearing. So shearing is when you have two things moving in opposite directions, kind of tearing side to side. It's not squishing, it's not pulling, it's kind of a sideways twist. And so shearing is a force that pushes rock to move in opposite directions. So similar to a transform boundary with plate tectonics, and we'll get to see how these are connected in a moment. With shearing, you would have something, if I've still got this squished piece of silly putty, you can kind of pull it to the side and it's going to be moving kind of like that. Silly putty, though, is a lot more moldable than hard rock. Hard rock is just going to snap, and we'll talk about what that creates. Now, before we get into the faults, we got to get something about hanging walls and footwalls. So in a fault, the hanging wall hangs over the footwall. And so in this picture, you can kind of see that you've got layers of rock. So we've got these flat horizontal layers. They're alternating colors. And right in the middle, you can see that you've got this crack, this fault. And the hanging wall is this one. This is the hanging wall. You can see that it's actually leaning over or hanging on the footwall. And that's the easiest way to explain it, and it'll help you to explain what's going on. My recommendation actually would be that you would draw something on your page And so maybe on the side, maybe you're next to it, just draw a simple little rectangle and a simple line through it, and then an H and an F for hanging wall and footwall. And this little diagram will help you be able to visualize it when we do the lab. Now the types of faults, get this down as a header, 3 types of faults as a header. And as usual, like I said, we're going to get each of these in their own thing, normal, reverse, and strike slip. Get 3 types of faults on there. The first type of fault. Now I'm going to play this video that we watched last time just in the background. The first type of fault is a normal fault. The motion is hanging wall moves up compared to the footwall. Okay? So the hanging wall is going to move up, and in this diagram, in the diagram down here, you can actually see that here's the fault. This right here is the fault. And the hanging wall has moved down. Compared. And how do we know it moved down? Well, if I change the color, you've got a layer of white right here, a layer of white, and a layer of white down here, a layer of white right here as well. You've got dark, 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 dark. And so if we just draw a line connecting in another color, I'll say there's the white line, there was the white line. The one that's hanging over is this one. So that's hanging wall. And how did the hanging wall move? It moved down. So we can tell that it's a normal fault. These are caused by tension. Okay? They're caused by tension and created at divergent boundaries. And so that's why I'm playing the divergent boundary video on the top, because it's showing the Earth being pulled apart and creating normal faults. Next, reverse faults. The motion, the hanging wall moves up compared to the footwall. This is caused by compression and created at convergent boundaries. Now if we do the same process with the last one, let's find the fault. So we can identify the fault as this crack right here. And we can identify layers that look the same, so we'll use this golden layer right there. We use the top of it, top of the golden layer. We can even say this white layer right here. White layer and white layer. Now, which way did it move? We need to find the hanging wall. So which one is hanging over? It would be this one. Hanging wall. And which way did the hanging wall move? We can see that the hanging wall, because of these layers have actually moved up. You can see this layer is here, and now it's gone this way. So we know that the hanging wall has actually moved up. It's moved up, and we know it's a reverse fault. Third type of fault, the third and final, is a strike slip fault. Now the motion is that the plates move past each other sideways. So you can see that just like with that plate video, we've got transform boundary, we've got that vertical view, and this is not a side view of rock, this is a vertical view. This is a field for crops. And so I'm going to get this little video playing that shows that. This is caused by shearing, and it's created at transform boundaries. So right up here you can see that earth snapping. It shifts, and eventually you'll see that this river has actually been moved apart. These crops right here are going to move apart when more and more tension is created. And you can see down here, these crops have been moved. So where's the fault? We can identify that. The fault is this line right here. And let's identify some layers. So these aren't rock layers, but they're crop layers, something on the surface. So we could say this right here and this right here. They must have been connected. We could say this right here and this right here. And if we look at it, we don't have a hanging wall or a footwall because it's flat. The layers are separated. And so we just have to identify that this is a strike slip fault because it's been a a motion that's happened on the surface of the earth. And so when you look at this, you don't need to identify which way it went. We can tell that the land that this land moved this way. So this kind of moved in that direction, and this moved that direction. So you've got 3 types of plate boundaries, 3 types of stresses, 3 types of faults. That's 9 things, but they're all connected. They're sets of 3, and they connect together. So hopefully you guys can kind of combine those and make sense of them. They really do connect on a global scale, and this is how we connect plate tectonics with earthquakes, because plate tectonics cause earthquakes to happen. I hope this was helpful.